Okay, so this one says consider the graph of an equation. So we have two expressions. We have a rational expression on the left-hand side of the graph, right? Now, that when I say rational, that's a fancy word for fraction. Okay. And then on the right-hand side, we have this 3 to the x plus 1. Now, this the red line is the 3 to the x plus 1, and the blue line is the 2 over x plus 4. And they said in the next line, it says, approximate the solution to the given equation after 3 iterations of a successive approximation when x is about. And they're giving us a number that they think that we should do. So when they say a solution from a mathematical standpoint is a value that both expressions share. In other words, what value of x causes them to equal the same amount? What value of x can I plug into this equation, right? What value of x can I plug into this equation that will give me the same value when I plug it into this equation? Well, we see that it's a little bit more than -2, okay? So now this process of approximating, there's a couple different ways you can do it. Probably the easiest way is to graph it. But to be honest with you, when you graph it and I let the calculator do it, it's going to give me well, let's just do it and I'll explain it. It's easier to do it. So what I'm going to do is I'm going to graph the left-hand side of the equal sign, and I'm going to graph the right-hand side of the equal sign, and then we'll see where they cross. Okay. Oops, I don't want the teacher view. I want the LCD. Oh, what do we do? Yikes. Wait for the program to close the program. All right. So I need to do this. All right, cool. Now we're cooking with gas. So I'm going to go to y equals, and in my y equals, the first thing I'm going to do is I'm going to put the left-hand side of the equal sign. So 2 divided by, now this is the important part, the entire denominator has to be in parentheses. Otherwise, the calculator doesn't know what's the numerator and what's the denominator. Okay. Then I'm going to take the right-hand side of the equal sign, and I'm going to put that in a second equation. All right. And, oh boy, plus 1. And just so it kind of matches the graph, because I don't want any confusion, I'm going to switch the colors around. So this is red, just like the original function. And I'm going to switch this one around so it's blue. All right. So now I'm going to graph that. And what I'm looking for is where they intersect. So if I hit second, and then see this word where it says calc, that's the calculate menu. Option number 5 is the intersect. So what this does is the calculator approximates the intersection. So what I want to do is I want to get as close as I can to where I think they're going to intersect on the first curve. That's the first equation. And then as close as I think I can on the second equation. I'm not really sure. And then it wants me to guess. So that gives me negative 2.168. Okay. So I'm going to write this down. So let me take a screenshot of this. The problem is that what is that as a fraction? Because actually, believe it or not, it wants you to convert it to a fraction when you do this online. So I have a value here. My calculator helped me figure it out. And what is that as a fraction? So there's a drop-down menu, and basically what you've got to do is plug in the fractions until you get one that's close to this value. So one of the drop-down options is negative 35 divided by 16. And that's the closest one. It's negative 2.8, negative 2.1875. So we're going to go with that answer. Now, you might say, Mr. Adams, why is it so off? Well, I could go back into the calculator and zoom in a little bit now that I know what it is and get a little closer. So if I adjust my zoom window or go to window instead, and I go from -3 and to -1 in the x direction, and then on the y, I go from -2 to say 5. Now when I graph this, I might be able to get a little bit better intersection. So I probably should have done that in the beginning. But now if I hit second calc, go down to intersect, now I can get really close to the intersection. And so my approximation should be better. So that looks like, see how that's already at 2.18. Oh, shoot. There is no undo on this thing. Still gave me the same answer, though. Huh. Interesting. All right. Well, that's basically it. This is the answer. Okay. That's why this is called approximating. Now, you could go through and solve this algebraically, but sometimes, especially in physics applications or engineering principles, very close, like it doesn't have to be exactly, that's 1/100th, right? If I get pretty close to the whole number, that's okay. So to solve that algebraically would be very challenging. But if you can get a very close approximation by using a calculator or something like that.